Hello dear students, this is Pradesh Chaudhary, your quantum guru. This video I'm going to discuss a very challenging problem of rigid body dynamics from 200 puzzling physics problems. So here is this question. The question states, in a physics 10, two balls of equal density of radius r and 2 are placed with the center of the larger one at the middle of the cart of mass capital M and length L. The mass of the smaller ball is small m. The balls are made to roll without slipping in such a way that the larger ball rests on the cart, and a straight line connecting their centers remains at a constant angle phi or theta to the horizontal. The cart is pulled by a horizontal force in the direction shown in the figure. We have to find what is the magnitude of that constant force and how much time elapses before the ball falls off the cart. So as described in the question, the radius of the smaller one is r and the radius of the bigger one is 2r. So obviously the mass of the bigger one would be the 8 times of the mass of the smaller one. They are made of the same material, so the mass of the bigger sphere is the 8 times of the mass of the smaller sphere. So that is the 8 small m. And what is given that the center line joining the center always makes same angle from the horizontal, that theta. So that requires that the acceleration of the center mass must be equal, otherwise the line joining the center will rotate. And at the same time, they keep rolling without slipping, meaning there is no slipping between any two surfaces. So now let's draw the forces acting on the systems, various parts. First of all, let's see the cart. Because there is no slipping between any surfaces, so the friction involved would be the static friction. Good thing about static friction is that it can have any value between 0 to f max and any direction depending on the requirement. So you can choose your own direction. If the answer is right, your direction that chosen is right, so answer will come positive. If the direction that you have chosen is wrong, so answer will come negative, and then you can correct. So let me assume that the friction on this capital M is acting in the backward direction, and let me assume that friction is a small f1, static friction. And mg normal I'm not showing because the motion is in the horizontal direction. So because of these two forces, the acceleration of the cart is say a1. Now I'm going to draw the FBD of atom. In the FBD, I'll not show the weight of atom and the normal by the cart because they will neither contribute to any acceleration of center mass because they are acting in the vertical direction, nor will they contribute to any angular acceleration because their line of action is passing through center mass. So first of all, to begin with, I am showing the reaction of F1 that will be in the forward direction and a normal from small m, and that will be like that. So I begin with these two forces. Obviously, there will be a friction between these two surfaces, but I have not yet shown. Because of this F1 and N, let me assume that the acceleration of the center of mass of atom is say A1 in the A2 in the forward direction like this. And N will not give any torque. Its line is passing through center mass. F1 will give torque in the anti-clockwise direction. So because of that F1, there will be an angular acceleration alpha 2. And acceleration of m, we just told that will also be the acceleration of the central mass of the smaller mass will also be a2. If these acceleration are not same, then this line will rotate. So there is no slipping between these two spheres, mean the acceleration of this point would be same for this sphere also and this sphere also, otherwise there will be slipping. So with respect to the center of this sphere, there will be an acceleration 2r alpha 2 and plus a2 will have to add. And with respect to center of this sphere, there should also be the same acceleration in this direction. Only then there will not be any slipping. So it requires that if with respect to the center of smaller sphere, this point has an acceleration along this direction, so it means there should be an angular acceleration like this. in the clockwise direction. So angular acceleration of small m will be in the clockwise direction, and let me assume that to be say alpha 1, like this. And now this angular acceleration, if I draw the FBD of this, there will be weight and the reaction of this normal m. The weight and normal cannot give any torque, hence can't give any angular acceleration. So this alpha 1 must come from the friction. So alpha 1 is along this direction, so it requires that the friction on small m must be along this direction. Obviously tangential, but along this direction. So let me write that friction is say F2, and the reaction of this n is n. These are action reaction pair, and obviously it's weight. So these three forces are acting on small m. And now there was one more force that was remained. The reaction of this F2 on the atom will be in this direction. It is also F2. And this is a line, vertical line parallel to this line, obviously a vertical line. So this angle is theta, so this angle is theta, and this is theta, and this is theta. Now we can proceed to write the equations of motion. For the cart first, in the along the horizontal direction, net force is capital F minus F1, and the expression is A1. So its equation is capital F minus F1 is equal to capital M into A1. That is this equation. Now for the atom, I want to write the F external is equal to MACM along the horizontal direction. So along the horizontal right direction, the net force. First of all, there is a one component of F2, that is a F2 sine theta, and there is a F1, and there is a one component of N in the backward direction, that is N sine theta. So net force along the forward direction on this atom is F1 plus F2 sine theta minus N cos theta, and that should be equal to atom into A2. So that is my second equation. F1 plus F2 sine theta minus N cos theta is equal to atom A2. And same way, let me write the equation of motion for this smaller sphere along the horizontal direction. So see, the component of n along the horizontal direction would be how much? That would be n cos theta. This, if I make a horizontal line, so that n vector makes angle theta with the horizontal. So n cos theta, and component of F2 along horizontal direction would be F sin theta in the backward direction. So net force on this along horizontal direction is n cos theta minus F2 sin theta, and that is equal to m into A2. So this is the equation for this smaller mass along horizontal direction. In the vertical direction, it is in equilibrium because the center mass only translates, so it has no motion in the vertical direction. So balancing forces along vertical direction. So this n will have a component in the vertical direction n sine theta, F2 will have component F2 cos theta, and that will be equal to mg. So n sine theta plus F2 cos theta is equal to small mg. So all the translational motion equation written, and now some constant part. Because there is no slipping at this point, so this point of the atom hemisphere and this point of the m hemisphere should have the same acceleration. And from here, if we see, the acceleration will be 2r alpha 2, and from here acceleration will be how much? Small r alpha 1. So r alpha 1 is equal to 2r alpha 2. It means the alpha 1 is equal to 2 alpha 2. That is my equation number 5. And then the constant part from here to here. You see, this has an acceleration a2, and it is rotating with acceleration alpha 2. So this point of the atom hemisphere should have acceleration a2 plus 2r alpha 2. And because there is no slipping between this and this, so this acceleration and this acceleration will be same. So a1 is equal to a2 plus 2r alpha 2. And now finally, 2 torque equation. For this, let me apply the torque about the center of mass on the atom. So torque is coming from F2 and F1. So F1 will have a torque in the direction of alpha 2, and F2 will have a torque opposite to alpha 2. F1 will rotate like this, F2 will rotate like this. So torque about the center of mass is F1 minus F2 into 2R. And that will equal to ICM into alpha. Its moment of inertia is 2 by 5 total mass into radius square. So I will write first of all torque F1 minus F2 into 2R. Moment of inertia is 2 by 5 into total mass, that is 8 m, into radius square, that is a 2R whole square, and multiplied by the angular acceleration, that is alpha 2. Simplify all this thing, this 2R, and from here 2 and 1R will get cancelled. So I'll get F1 minus F2 is equal to 32 m R alpha 2 by 5. That is my equation number 7. And then let me apply the torque equation for the smaller sphere, applying torque about the center of mass. So F2 will give torque. So torque is F2 into R is equal to I into alpha. Its moment of inertia is 2 by 5 mr square, and alpha is alpha 1. So equation is F2R is equal to 2 by 5 mr square alpha 1. Get 1R cancel. So we'll have F2 is equal to 2 by 5 mr alpha 1. So all physics done. Now it's only matter of solving all these 8 equations. What is us? We have to find F. In F, we'll use this equation. So I need, out of these 8 equations, I need to find F1 and A1. And then there is a one part in which at what time they will fall off. So for that we need the relative displacement and relative acceleration. So I also need to find A2 so that I can get the relative acceleration. So basically I'm interested in the three things: F1, A1 and A2. So let me go next page and solve. So these are the 8 equations. A lot of equations, and we have to just arrange them to get the solution. So first of all, what I want to do, I want to add equation 2 and 3. Equation 2. See, if I add equation 2 and 3, this minus n cos theta and n cos theta will get cancelled, and this f2 sin theta and minus f2 sin theta will add up to 0. So on the LHS I will remain with f1, and on the RHS will get 9m8. So adding them will get f1 is equal to 9m8. And now what we want to do, one more thing. See, we want to do this operation. So this is equation 4. I want to multiply this equation 4 by cos theta, equation 3 by sin theta, and then subtract. See, if I multiply equation 4 by cos theta, that will become n sin theta into cos theta, f2 cos square theta, and there will be mg cos theta, and if I multiply this by sin theta, that will become n sin theta into cos theta minus f2 sin square theta is equal to m into sin theta. So if I subtract this from this, so n part will get cancelled and f2 part will get added up. That will become f2 cos square theta plus sin square theta, and that will become f2. On the RHS, that will become mg cos theta minus m into sin theta. So we will get f2 is equal to mg cos theta minus ma2 sin theta. And from this equation 9, I can use the value of ma2, which is f1 by 9. So f2 is equal to mg cos theta minus f1 by 9 sin theta. From in place of ma2, I use f1 by 9. So let me take this f1 part on the LHS. So I will have one equation on f1 and f2, that is f2 plus f1 by 9 sin theta is equal to mg cos theta. So I've got one equation in f1 and f2. And see now what we can do. From here you can see equation 7. Equation 7 is f1 minus f2 is equal to 32 by 5 mr alpha 2. And 2 alpha 2 is alpha 1. So in place of r alpha 2, I can write r alpha 1 by 2. So that will become 16 by 5 r alpha 1. So that is another thing. And now r alpha 1, from here you see this r alpha 1 is 5 f2 by 2. So 16 by 5 into, in place of r alpha 1, we are putting 5 f2 by 2. So that is 8 f2. Take 8 this f2 on this side, so we'll have a relation on f1 and f2. What will be there? That is f1 is equal to 9 f2. So if I can put on here, So you can see F1 by 9 is F2. So if I put it here, so that will be F2 plus F2 sine theta, that is F2 into 1 plus sine theta on the RHS, that is mg cos theta. So F1 we get mg cos theta upon 1 plus sine theta. Sorry, F2. Let me repeat what I am doing. F1 by 9 is F2. So in place of F1 by 9, I'll put F2. So that will become F2 into 1 plus sine theta, that is mg cos theta. So F2 is equal to mg cos theta upon 1 plus sine theta. And then F1 is 9 F2. So whatever F2, just multiply by 9. So we'll get F2. So we've solved F1 and F2. And now use this thing. A1 is equal to A2 plus 2R alpha 2. Before that, we can also write A2 from here. A2 is equal to F1 by 9m. So F1 by 9m, if I put F1 by 9m, so that will be g cos theta upon 1 plus sine theta. So that is A2. For A1, I'll use this equation. A1 is equal to A2 plus 2R alpha 2. A1 is equal to A2 plus 2R alpha 2. And 2R alpha 2 is basically R alpha 1. See, 2 alpha 2 is equal to alpha 1. So 2R alpha 2 is equal to R alpha 1. And R alpha 1 from here is F2, 5F2 by 2n. So A2 plus 5F2 by 2n. And put the value of F2 from here and A2 from here. So this here I have written A2 from here, g cos theta upon 1 plus sine theta. And 5 by 2 F2 by m. F2 by m, see F2 by m from here you can see F2 by m is nothing but A2 only. F2 by m is A2. So F2 by m A2, so that is a 5 by 2 g sine theta upon 1 plus sine theta. So adding this, we get A1 is equal to 7 by 2 g sine theta upon 1 plus cos theta. So all the important thing we have solved. Alpha 1, alpha 2 not required for those two parts. So let's take these results on this part. A1, A2, F1 we solved. And C. Use this equation. F minus F1 is equal to MA1. We have to find what is the required force to pull the card so that the line joining the center always remain horizontal. So using this equation 1, F is equal to F1 plus MA1. So F is equal to F1 plus M1. Write the value of F1 here and A1 here. In both these, what is there that you can see in F1, g cos theta upon 1 plus sine theta, and in A1 g cos theta upon 1 plus sine theta is common. So take that thing common, and then in F1 another thing that will be 9m, and there m A1, so from m will come here and A1 7 by 2 will come, so that will be 7 by 2 capital M. So that is this. So we got the value of F. And one more thing that was asked, that at what time the sphere will fall off. So let's see the diagram once again. See, that is the diagram. Actually, this length is given to be L. So the relative acceleration of the center of mass is A1 minus A2. A1 is more. So with respect to this, the center of this sphere has an acceleration A1 minus A2 in the backward direction. So when this line will come here, that is just about to fall, and when it goes a little more, it will fall. So relative displacement, it has to cover L by 2. And relative acceleration is A1 minus A2. So using the second equation, S relative is equal to half A relative T square. A relative is A1 minus A2. A1 minus A2 is 5 by 2 g cos theta upon 1 plus sine theta. So, and S relative is L. S relative is L by 2. So T is equal to square root of L by A relative. And put the value of A relative, we will get square root of 2L 1 plus sine theta upon 5g cos theta. So this was a very good question. A lot of concepts were involved, like the concept of torque, concept of no slipping, kinematics concept, and the relative motion concept. And of course, there were a lot of equations, so solving them in time is also a skill. So if you like this video, please hit the like button. And if you haven't subscribed to my channel, please do subscribe and share this video. Thank you.